So at this point we've done linear equations and quadratic equations. So now we're going to start talking about what happens whenever the power is really a fraction. So when is it a square root or a cube root, also known as a radical. So what we're going to look at are radical equations. So a radical equation is when we have, so these are equations with square roots, cube roots, etc. So anytime we have a square root or a cube root or anything like that, we're going to call those radical equations. Now the thing about radical equations is you're going to solve for the variable, but a lot of times solutions are called extraneous solutions, so you always have to check to make sure that they actually worked. So kind of important here is that radical equations can result in extraneous solutions. So we always have to check our work. So we always, and this is just for radical equations, so you always have to check any of your solutions. With quadratics we didn't have to do that, with linear we didn't have to do that, but with radical equations we're always going to have to do that. So how are we going to solve radical equations? Well, the process is to get the radical on one side of the equal sign. So one side of the equation. So you're going to get the radical on one side of the equation, then you're going to raise it to an appropriate power. Now what do I mean by appropriate power? Well, remember that anytime you have a root, so like a square root, that's the same as x to the 1/2. Or a cube root, that's the same as x to the 1/3. So if you have something like x to the 1/2 equals 3, the way you're going to, the appropriate power is whatever power you would multiply this number by to get 1. So what would you multiply 1/2 by to get 1? Well, that would be 2. So you're going to raise both sides to the 2 power, and that's going to make this a 1. So x equals 9. So if I had something like x to the 1/3 equals 2. So I want to figure out what power to raise it to. Well, what number multiplies to get by that to get 1? So it'd be 3. So I get 8. So once you raise both sides to the 3rd power, you would get 8. So let's do some examples of these radical equations. So first example. Let's say I have the square root of x minus 3 equals 2. So the process with radicals, remember, is first thing, get the radical by itself on one side of the equation. So the radical is not by itself over here, so what we're going to do is we're going to add 3 to both sides. So we get the square root of x is equal to 5. Okay? Now, the square root of x, remember, that's the same as x to the 1/2. So what power should I raise both sides to? I want to get the power that I multiply this by to get 1, so it's going to be a 2. So I get x equals 25. Now remember, with radical equations, I have to double check it. So we're going to check our solution over here. What I mean by check is go back to the original equation. Everywhere I see an x, put in a 25. So we're going to check x equals 25. So is it true that the square root of 25 minus 3 equals 2? So everywhere I saw an x, put in a 25. Let's see. Square root of 25 is 5. 5 minus 2 is 2. So yes. So x equals 25 is our solution. Okay. Let's try another example. How about the cube root of x plus 1 equals 3? Well, my radical is already by itself, so I don't have to worry about it there. The question is, what power should I raise both sides to? Remember, the cube root is the same as raising something to the 1/3. So how do I get rid of that? We'll cube both sides. What is 3 cubed? That's 27. So I cubed both sides and I got x plus 1 is 27. Now how am I going to solve for x? Well, I need to subtract that 1. So there's my answer, but we always have to check it. So we're going to check x equals 26. Go back to the original equation. So I'm going to go back to this one here, and I'm going to plug in 26 for x. So is it true that the cube root of 26 plus 1 equals 3? Is that a true statement? Well, 26 plus 1 is 27, and the cube root of 27 is 3. So yeah, this does work, and x equals 26 is the right answer. Okay, let's try example 3 here. How about 3 times the square root of 2x plus 5 equals negative 9. So I have 3 times the square root of 2x plus 5 equals negative 9. I get a couple choices here. I can divide by 3 first to get rid of that 3, or I can go ahead and square both sides. It doesn't matter. Let's say we divide by 3 first. So I'll get the square root of 2x plus 5 equals negative 3. Now what power should I raise it to? Well, I'm taking the square root. Remember, the square root is the same as raising it to the 1/2. So I'm going to square both sides. And negative 3 squared is 9, because negative 3 times negative 3 is 9. Now to solve for x, I'm going to subtract 5. So I get 2x is 4. Then I'm going to divide by 2 and get x equals 2. Okay, so I got x equals 2, but we gotta check it. So let's check x equals 2. Go back to my original equation. Everywhere I see an x, put a 2. And we're going to say, does this equal negative 9? So the square root, well, 2 times 2 is 4. 4 plus 5 is 9. So this is really the square root, 3 times the square root of 9. The square root of 9 is 3. So I get 3 times 3. Well, 3 times 3 is 9. Is that equal to negative 9? No, it's not. So this is not a solution. What does that mean for us? That means there are no solutions to this problem, because we only had one possibility, and that possibility didn't work, so we have no solutions. Okay. Next example. Let's try x minus 3 equals the square root of 30 minus 2x. My radical is already by itself, so I don't have to worry about getting it by itself. So I'm just going to go ahead and raise it to the appropriate power. So over here I'll square, and then once I square on the right, it just gets rid of the radical. Now I need to be careful. X minus 3 squared, I'm going to do that off to the side here. Remember, x minus 3 squared is x minus 3 times x minus 3. Well, that means I have to distribute twice. So it'll be x squared minus 3x, then minus 3x plus 9, which gives me x squared minus 6x plus 9. It's not x squared plus 9. Right, you don't just square both terms. You gotta square the whole left-hand side. So I get x squared minus 6x plus 9 equals 30 minus 2x. Now let's try to solve this for x. Well, this is a quadratic, so how do you solve quadratics? Well, first you gotta get them set equal to 0. So I'm gonna add 2x to both sides and subtract 30 from both sides. So when I do that, I get x squared minus 4x minus 21 equals 0. Now we want to solve this. Now we can do any of the methods. We could complete the square, we could try to factor, use the quadratic formula. I think this actually factors pretty nicely. I think this factors as x minus 7, x plus 3. And if you don't believe me, you can use the quadratic formula and double check it. So that tells me either x minus 7 is 0, so x equals 7, or x plus 3 equals 0, so x equals minus 3. Those are our two choices. We've got to check to see if one of them or both of them work. So let's first check x equals 7. So I'll go back to my original equation. Everywhere I see an x, put a 7. So is it true that 7 minus 3 is equal to the square root of 30 minus 2 times 7? Let's see, 30 minus 2 times 7, that's 16. So I get 4 on my right hand side. Is it true that 7 minus 3 is equal to that? Well, yeah, 4 equals 4. So x equals 7 works. Now let's check x equals negative 3. So go back to my original equation. Is it true that negative 3 minus 3 equals the square root of 30 minus 2 times negative 3? Let's see, over here I'm going to get the square root of 36, which is equal to 6. Over here I get minus 6. Are those equal? No, so this is not a solution. So the only solution is x equals 7. So just kind of reiterate here. Whenever you have a radical equation, what you're going to do is get the radical by itself, raise to an appropriate power and solve for x, and then make sure and check your work. You got to check your work with radical equations.